Welcome to The Explainer. Today, we are heading right to the edge of what we know, or what we think we know, about physics. We're going to be looking at a brand new map, not of our world, but of all the worlds that could possibly exist. So, let's just jump right in with a massive question. Could reality have been different? I mean, is there only one way to build a universe? For a long time, we kind of thought so, but string theory, which is one of our best shots at a theory of everything, just blows that idea out of the water. It suggests our universe is just one option out of a huge, sprawling landscape of possibilities, and each one of those possibilities has its own unique rulebook for how physics works.
And physicists have a name for this whole idea, the landscape of theories. The best way to think about it is like a library that goes on forever. Every single book on every shelf describes a totally different universe, with different particles, different forces, a completely different reality. So if there are just countless sets of physical laws out there, what in the world are they? And are there any fundamental principles that shape them all?
And here's why this matters. The crucial point is that mapping this landscape isn't just some abstract math problem. No, it's actually a vital step toward answering maybe the deepest question we can ask. Why is our reality the way it is, right? Why these specific laws and not any of the other infinite options? Okay, so how on earth do you even start to chart something so enormous? You can't map everything all at once, that's for sure. So scientists have started with a more manageable, but still deeply mysterious, little corner of this landscape. They set out to create a complete list of all possible universes with 6 dimensions. Now, these aren't just fantasy worlds for the fun of it. They're actually incredibly useful theoretical laboratories called 60 Superconformal Field Theories, or SCFTs for short. You can think of them as these perfect, pristine environments. And they're studied in 6 dimensions because that's the highest dimension where these supersymmetric theories can even exist. In these 60 worlds, the basic rules of quantum physics can be seen in their absolute purest form, and they act as the building blocks for more realistic theories, like our own.
For the longest time, physicists only knew about a handful of these 60 theories, but a really monumental research project set out to change all of that. Their goal was to create a complete catalog, a definitive atlas of all of these possible theoretical worlds.
So, how do you even find them? You can't just make them up, right? Well, the secret weapon here is this remarkable tool that comes from string theory called F-theory. And what it does is reveal this absolutely stunning connection between the laws of physics and the laws of geometry.
Let's break this down a bit. You can basically think of F-theory as a kind of universe-building machine. You start by feeding it a simple geometric shape. That's your blueprint. The machine then processes this blueprint using its rules, and what comes out the other end is a fully formed, complex physical theory, complete with its own set of forces and particles.
And this is the key insight, the really cool part. It's a direct translation. The specific features on that geometric blueprint, little defects, or what are called singularities, those are the hotspots where all the interesting physics, the forces and the matter, actually pop into existence. You change the geometry of the blueprint, and you literally change the physics of the universe it creates.
So what this really meant was that the main goal of the research was to forge these blueprints. They had to find all of the fundamental, minimal designs that this F-theory machine could use to build a stable, consistent universe that actually makes sense. And here's the catch. Not every geometric shape will work. A lot of them are unstable. And if you feed them into the machine, you just get mathematical gibberish out, a theory that's totally unphysical. The real challenge is to sift through all the possibilities to find the core, stable designs. And physicists call these endpoint configurations. Those are the ones that actually count.
So how do you sort the good blueprints from the bad ones? Well, to do this, the researchers came up with this incredibly powerful procedure. If a blueprint turns out to be unstable, this algorithm they created systematically blows up points on its surface. It's basically adding new components to repair the design until it becomes stable and consistent.
And this gives you a little peek at how that works. Imagine you start with a blueprint made of 2 simple geometric pieces that cross over each other. Let's just call that configuration 33. The rules of F-theory tell us that this intersection is unstable, it just doesn't work. So the blow-up algorithm kicks in. It surgically modifies that unstable spot, inserting a brand new geometric piece right between the original 2. And the result? A new, stable blueprint that's now labeled 414. By doing this over and over, they could find all the fundamental stable designs. So, after applying this method to all the possible starting points, what do they find? This is where it gets really good. We're opening a totally new atlas of worlds.
By exhaustively checking and fixing countless geometric designs, the researchers didn't just find a few new theories, they stumbled upon a vast hidden continent of possibilities.
The result was, well, pretty astonishing. They found not one, but two new infinite families of 60 theories. This just dramatically expanded our map of the theoretical landscape. But even better, these infinite families weren't just some random mess. They actually followed this shockingly elegant and predictable structure.
It turns out all these new universes are incredibly organized. It's almost like a periodic table for reality itself. They all fall into two main families, called A-type and D-type, which are built from simple chains of geometric parts, either straight lines or branched ones. And the ends of these infinite chains are always finished off with one of just a few specific geometric endcaps. It's incredible. It means that out of infinite possibilities, this elegant and finite set of rules just emerges, governing how all of these potential worlds can be built.
Okay, so we have this amazing new atlas of imaginary, six-dimensional worlds. It's a huge achievement for sure. But what does it all mean for us? This is the crucial part, right? Mapping the rules of reality. Why should a map of 60 worlds matter to us here in our 4D universe?
Well, the answer is pretty profound. By understanding the full range of what is mathematically possible in any universe, we start to get powerful new clues about what makes our own universe actual. This isn't just a map. As the researchers themselves put it, it's a theoretical laboratory.
Think about it like this. Every single one of these theories, every rule, every constraint they discovered on this map, it's a piece of the ultimate puzzle. By mapping out the boundaries of what's allowed in the entire landscape of physics, we begin to see the deep principles that might have forced our universe into the specific form that it has.
So this incredible work gives us a stunningly detailed map of what could be, but it also sharpens our focus on the next great mystery. With this amazing atlas of possibilities in hand, the ultimate question becomes clearer than ever. Out of this vast, structured landscape of potential realities, what principle, what mechanism, what thing selected ours?